Hello, my name is Michael Robinette, and I'm here with Jackson Lipford. We also worked with Joao Franco and Ray Tiffin on exploring the potential for diversity in the Schelling model. So, what is the Schelling model? Thomas Schelling in 1971 introduced a simple segregation model in which agents of two colors are distributed randomly on a grid. Some squares are left unoccupied. An agent is satisfied if half or more of its neighbors are of the same type. An agent will randomly move until this condition is satisfied. Here's an example of a Schelling grid with red and blue cells at time 0. Also, fun fact, in the very first issue of the Journal of Mathematical Sociology, James Sakota published an article entitled The Checkerboard Model of Social Interaction. Sakota's article went more or less unrecognized. Yet a careful comparison demonstrates that, in a certain sense, the Schelling model is just an instance of Sakota's model. And this is why Peter Dodd says we shouldn't name things after people. So what is the significance of this Schelling model? Segregation can emerge in somewhat mild circumstances. Also, in the modeling world, it introduced this concept of a behavioral threshold that inspired a number of other models of collective social behavior. The question we wanted to think about was, how can we influence diversity using externalities in the context of the Schelling model? We were interested in the impact of both positive and negative externalities. One could think of positive and negative externalities in a variety of ways. For positive, think of great schools, and for negative, think of something like toxic waste dumps. Our approach was as follows. We started by making a traditional Schelling model. We initialized a 20 by 20 grid with non-periodic boundaries. We filled that grid with red and blue cells according to density and ratio parameters. Finally, we used a function for evaluating happiness. A cell will examine the proportion of similar and different neighbors in its Moore neighborhood. If the neighborhood is more diverse than its tolerance threshold, 50% in the original model, then it will search the grid for an empty cell in a neighborhood below its tolerance threshold and move there. Then another random active cell will repeat this process until all cells are happy with their neighborhood. That's the basic Schelling model. Our twist involves setting a portion of active cells as positive and negative externalities, then seeing how they altered our dependent variables of time to happiness and diversity. We think of positive externalities as grandmas who bake cookies for everyone in their neighborhood. Any cell with a grandma in their neighborhood will be happy regardless of diversity. Negative externalities are drummers who practice their drums late into the night. Cells with drummers in their neighborhood will always be unhappy regardless of diversity. And with that, I'm going to pass it over to Jackson to talk about our results.
Thank you, Michael. We examined 4 main scenarios. First, the basic Schelling model with no externalities. Next, 10% of active cells as grandmas. Then 10% as drummers. Finally, 5% of grandmas and 5% drummers. Here's an example of a typical run of the base Schelling model with the starting grid on the left, finished grid in the middle, and a plot of happiness and diversity on the right. Our average moves to happiness were 77.9, and our average final diversity was 9.91%. Note how the grid starts fairly diverse, with reds and blues mixed evenly, then settles into distinct red and blue areas by the end. Next, we have a run with 10% of active cells as grandmas, pictured in green. As you can see, we cut down average moves to happiness by about 40%, down to 46.4, while preserving about 30% more diversity. Note how neighborhoods with a grandma tend to be more diverse. Next, we have 10% of active cells as drummers, pictured in yellow. The time to reach maximum happiness just about doubles, up to 130.7, while diversity is almost identical to our original model. As you can see, drummers create pockets of empty space around them, which functionally reduces the size of the grid. Finally, we have a mix of 5% grannies and 5% drummers. While the average moves to happiness is pretty close to our initial condition at 82.4, our diversity is about 20% higher. Drummers are still creating pockets of space in the grid, but grandmas are mediating some of the segregation. To conclude, positive externalities increased diversity while decreasing time for the model to reach maximum happiness. Negative externalities didn't change final diversity, but did increase time for the model to reach happiness. We also had a few ideas for further research that we weren't able to implement. A price system could be introduced, making some of the grid squares more expensive than others, while certain cells are more price sensitive. Tolerance values could be randomly assigned or made different systematically between red and blue cells. Certain cells could be hipsters and move to neighborhoods with high difference. Anyways, thank you for watching.
Thanks for watching. Happy modeling.